Hello everyone, welcome back to Analyst Chronicles channel. So today I'm gonna go through with a new machine learning algorithm, which is a decision tree. Since we covered, I have already made a video on uh, linear regression, which is useful for continuous variables. For example, if my target variable is a continuous variable, then we can use linear regression, and also for uh, in classification problems. So decision tree algorithm can be used for multi-class classification. So for binary class classification, so we worked on logistic regression. So logistic regression is a classification machine learning model, but it could be useful when we have a binary class, nothing but when we have two classes. So my output variable or my target variable has two categories, like then we can use logistic regression. It will give us a good fit or good results. So we can train logistic regression model for binary class classification. So whereas if I have multi-class classification, so decision tree algorithm can be useful. So this is also comes under I mean, this is also for categorical variables, but multi-class, I mean, categorical variables, no more than two. Multi-class means more than two. So I have categories of more than two. It could be 3, 4, 5, 6, 7, 2 plus. It could be anything. So here we are going to work with a wine data set. So which is in-built data set from scikit-learn. So I'm going to import the data set from scikit-learn, and we are going to test the quality of the wine. So from the inbuilt data set, so we are gonna train the model and we are going to predict some outputs, and also I'm gonna give, or I'm gonna feed a new data set, like new variables at the end of the model once the model has trained. So I'll try to pass the new data set, and at the same time, so we will gonna look at the how the machine, the how the model is behaving, like are we getting, I mean, like what is the precision, accuracy. So we are gonna evaluate the model as well. So without any delay, let's jump into the today's video. So let me import all the necessary libraries first. So I'm importing pandas as PD for data manipulation, and importing numpy as np for mathematical computations. Import matplotlib dot pyplot as plt for visualization part. And also I want to use cbon as sns for advanced visualizations. So, and also import warnings. Don't want to see any warnings. Warnings dot filter warnings. Ignore the. So these are all the basic libraries for the data analysis, mathematical computation, and also to visualize the data. So now let's jump into the scikit-learn. So where we need to import from sklearn dot model selection, import train test split to train, to split the data into training dataset and testing dataset. Okay. Train test split. Okay, so we imported train test split, and also we need to import from sklearn dot datasets. Datasets need to import wine dataset. So we have a lot of datasets available in within the sklearn. So today we are gonna work with multi-class classification problem. So that is the reason why I'm using this wine dataset, where we have uh, I mean, let's talk about the data sets. Once we are able to import the, I mean, data. So I want to load the data set. So I imported wine data set, and also I want to import a model scikit-learn.tree. So if I wanted to import the decision tree algorithm, so I need to use scikit-learn.tree import decision tree classifier. Okay, so and if I wanted to evaluate my model, scikit-learn dot metrics. So we need to import confusion matrix and classification report. So these two methods are enough to evaluate the model. So I'm just importing confusion matrix as well as classification report. So I think this is enough. Okay, we imported train test split to split the data for training dataset and testing dataset, and also dataset imported, and also the model decision tree classifier model, and also if I wanted to the model evaluation part also done. So okay, let's run this cell. Okay, now I'm naming my dataset name is equal to wine, and so my dataset from the sklearn is load wine. So load wine. Now we are able to get the okay. So my dataset has these keys: data, target, frame, target names, description, and feature names. So let me look at the description of my dataset. Wine.descr. It will give me the description about my dataset. Sorry. Okay, so here you can see there is a brief description about the, so it has from the ML wine recognition datasets, from UCI machinery, machine learning datasets, and also see you here you can see the data is the result of a chemical analysis of wines grown in the same region in Italy by 3 different cultivators. So there are 13 different measurements taken for different constituents found in the three type of wines, original owner something. So we have a brief description about all the data set, from where the data collected, and also who is the owner for this data set, and how, what are all the input features. So something like that, you can see the data here. Okay, that is how you can, if you wanted to look at the description of the data which is imported from the sklearn, so you can use the dataset dot description will give me the description about the dataset. So that is about a description, and let me give my x and y. So I need to assign um, so since I my feature names are my input variables features. So this is my uh, capital F. Okay, so now I'm able to define my input features. So let me look at the x dot head, how the data set look like. So this data set has 13 features, input features. So let me have a look at the input features by clicking or by doing info method. So here you can see, so we have 13 columns. The first column is alcohol, and the malic acid, ash, and alkalinity of ash, magnesium, total phenols, flavonoids, non-flavonoids, color intensity, HUE, diluted wines, proline, and also we have a target variable nothing but the quality of the wine. So we need to assign that as well. So y is equal to my data set is wine, and I need to assign the target. So it will give me my target variable. So if I wanted to see the y, so here you can see zeros, ones, and twos. So nothing but the quality of the wine. So it was divided into three different categories. So zero, nothing but like a one class, second class, first class, something like that. So the wine is classified into the quality of the wine is classified into three categories, and each represents each number. Zero represents one class, and one is representing one class, and two is representing different class. So based on these three different classes or categories, the wine is, I mean, the given input variables. So this is the output variables we have 0, 1, 2. So that is how you can get the data from sklearn, and also you need to I mean, you need to divide the data into input features and as well as the target variable. Because so why am I dividing the data for input features and as well as the target variable? Because based on the input features, the output is depending, like how the characteristics, this like alcohol, now the these numbers are measurements, malic acid as something like that. So based on these results, the wine, the category has been segregated, like if it is a fine quality or second quality or third quality wine, something like that, based on these characteristics. So since it is inbuilt data set from Kaggle, sorry, from sklearn, so we don't have to pre-process it. So it's already, I mean, normalized standardization has been done, and also no need to do the coding, also encoding, one hot encoding, because my target variables are 0, 1, 2 only. So if I have a category like class 1, class 2, class 3, or grade 1, grade 2, grade 3, so we cannot pass the numerical, sorry, alpha, like with the categories with the names. So we cannot pass or we cannot feed the alpha or the categories data to the model. So it has to be converted to the numeric digits by one hot encoder. So we don't have to do it in this scenario, because already the data has been encoded with the 0, 1, 2. So 0 being one category, 1 being a different category, and 2 being a different category. So we can able to understand that we have three qualities of wines being named 0, 1, 2 after standardization or after one hot encoding has been done. So this is how you can, I mean, name input features and a target variable. So now we wanted to train, and we need to or we need to split the data into training data set and testing data set. So train test split. So let me go through the syntax. So here you can see the train test split syntax. So my x variable, I have named my x as with the all input features, and my y is my output or target variable. Test size I'm giving 0.33, random state I'm giving 42. It is like your wish. If you wanted to test 50% data, you can pass 0.5. If you wanted to test 70% of data, mention the test size as 0.7. So that is up to your requirement and the data set we are working and the problem statement you are working. So that is up to the problem statement. We can use just test size and also the requirement we have and also the type of data set we are working on. And this random state is like 42 also. If you don't want to mention any number, randomly it will take the data, like every 40-second entry it will be random, I mean random, like randomly segregated, the data will be segregated randomly for every 40-second entry, something like that, random state. So you can put 1, 2, 3, anything as per your requirement. So that is how you can train, you can split the original data set into training and testing split. So let me run this and let me look at the training x train shape. So first I wanted to look at the original dataset shape also. So here if I wanted to see entire dataset shape, it has 178 entries, like 178 rows and 13 columns. So let me look at the X train. So how it got, so out of 178, so we are using 119 entries for training purpose. So we are going to use this 119 entries for to train the model. And also if I wanted to look at the X test, if I wanted to see the shape, see we are using 59 to test test the model. So we are using 119 entries for to train the model. So once we are done with the training, so we are gonna test the model with this 59 entries. So that is how you can split the data set with a given condition, like how much data you wanted to use for testing purpose, and also what is the random state you wanted to use. So that is how we can split the data into training and testing data sets. So now we are done with the training and testing part. Now we need to train the model. First model is equal to, so let me copy paste the decision tree classifier. So this is my model. So now if I wanted to fit the model, model dot fit, now I need to pass. So I need to train the model. So that is why I need to pass this training data sets, X train, Y train, Y train, so that the machine will train based on the data set. So now the machine has been successfully, I mean, we are able to train the model. So we passed X train and Y train dataset, training dataset. So machine is ready to predict the results. So if I wanted to predict, so predictions is equal to model dot predict. So I need to pass X test, because I need to see, I passed this X train Y train, so that a machine will train based on the training input features and how the why the target variables are there. So machine will look at the patterns, what are all the input features and how the why target variables are assigned based on the input features. So that is how machine trained within the this by with the values with X train and Y train. So with the trained model, now if I pass this testing data set X test, machine has to predict. So that is where we will get these results, predictions. So now I need to pass this X test. Then we can have a look at the predictions. Like, see here, these are my predicted values. So anyhow, we have the original values. These are like tested. We need to test it versus the predictions. So these values are based on this input features X test. But now machine is based on the model machine build. So we are passing this X test or testing data set to predict the model. So we need to compare this Y test and Y predict. So let me give this as Y predict. Since I assigned it to Y test, so it would be easy. Y pred. Okay, so now we can able to see the differences between the actual values, how the actual values are. These are all the actual values and these are all the predicted values. So let me look at the actual and predicted values. So that will be, we will get a some idea. So now we are able to train the model. Now I need to evaluate the model, how the model has been performing. So we need to look at the performance of the model. So we just imported this classification report as well as the confusion matrix. So and also, so I just wanted to see the accuracy score as well. So if I wanted to use this accuracy score, so I need to import it from the matrix as well. Accuracy score. Okay, I need to run this so that I'll be able to use. Now, if I run this, I will be able to get the accuracy of the and the classification report by passing y test and y predicted value. And if I wanted to see the confusion matrix, so this is how we can see the confusion matrix. Confusion matrix, I need to pass the original actual values and the predicted values. And if I wanted to look at the I mean, in a visualized manner, how the machine is predicting versus actual values. So let me run this, or else we'll do one thing. So let me plot this in the next cell. Sorry. So here I'm gonna run this so that I'll be able to get precision recall F1 score. So my precision is about 95% and accuracy is also 95%. So that means it's a good fit. I mean, machine is predicting similar to the actual values. So that is how you can see. And macro weighted average, macro average, everything is above 95%. So that is how you can have a look at the classification report and accuracy. So, and if I wanted to plot against actual and predicted values, so this is how the model is. So I just wanted to have a look at the heat map. So this is a confusion matrix, and my X labels are actual values. Sorry, X label is these are the predicted values and these are my actual values. So this is how you can see the confusion matrix. And so then you can have a better idea. So this is how we can evaluate the model which we trained. And also, if I wanted to test the model with a new data set, not the data points from the data sets. Now I wanted to pass a new data set which is not there within the data set. So so before passing a new data set, if I wanted to look at the comparison with the actual and predicted values, so this is how. So my actual value is 0 and also predicted value is 0. So that means machine is predicting the exactly 100% accuracy here. So here 0, 0, 2, 2, 0, 0, 1, 1. So I just had only dot head, only 5 values. So you can see the accuracy here. Accuracy is giving 95%. That means machine is predicting 95% of the data accurately, and 5% is like error, margin of error. Is machine is not predicting up to the like as the data we have actual data set. But 95% means the accuracy is very good. If I get a results with the 95 percentage of the accuracy rate. So this is my new data set. So based on my new features, I'm using this. I'm gonna pass these three variables for each column: alcohol, malic acid, ash. So something like that. I'm gonna pass these new variables to the model, and we'll see how the machine is predicting. If I run this, so my predictions are 0, 0, 0, 0. That means based on these characteristics or based on these input features, so the my machine is telling me that okay, these are all for the first zero. I mean zero, nothing but I can name zero as a fine quality of wine, and one is being first class, second being second class, something like that. So machine is telling me this wine, whatever I'm giving or feeding it to the, I mean the model, the which we built, and that model is telling me that okay, the wine you are using is fine quality wine. Since it is 0, 0, 0 giving, I am naming my zero as fine quality wine. So that is how you can feed the new data set to the model which we built. So this is how you can perform or you can build a machine learning model. So it is very simple. You just have to import all the necessary libraries for data manipulation. Since it is a inbuilt data set, so we are not gonna work much on data pre-processing and all those things. So if I wanted to use the data set from the sklearn, so you need to use the syntax sklearn dot datasets, and you need to import a required data set. And also, so if you wanted to import the model decision tree classifier, because we do have a regression models also. So if I wanted to predict a continuous variable, we can do that also with a decision tree algorithm. So decision tree can be used for regression and classification problems. So it is that is the advantage of a decision tree. So that is why we have two algorithms within the decision tree. So we need to import, since this is the classification problem, so we need to import a decision tree classifier. And if I wanted to evaluate the model, confusion matrix and classification report and accuracy score. And so I just imported the data and I have assigned my input features and also my target variable, and I split the data into training and testing. And this is my model. I imported the model, then model has been trained and I predicted. I just have a look, I just evaluated the model with this evaluation matrix. And also I had a look at the confusion matrix, how the confusion matrix is, I mean, how we can able to evaluate the model with the confusion matrix. So versus actual versus predicted. And also so this is like sample data set, how the actual and predicted values are. And also at the end, I use a different data set which is not there in the original data set, and I feed it the data to the trained model. Then my model is, I mean, giving me predictions accurately. It's 95 percentage of accuracy results. So this is my new predictions. So I hope it is very easy or simple. If you have a proper knowledge about the model or machine learning algorithm, then we can able to work on different kinds of data sets. So the algorithm or the steps are similar, but you need to understand the concept. So I hope so you are understanding, or you are getting, or you are able to understand the concepts in a easy way. So please do subscribe the channel so that it will encourage me to do more videos something like this. So don't forget to like the channel. Thanks everyone. Bye.